Very important. These concepts, we're going to review them a little bit at the beginning of each class. So we know that the derivative, which is f prime, of a function gives. And we reviewed these three things a minute ago. So can anyone give us what does the derivative say about the function? So the first derivative says something about the function. What does it say? I couldn't hear you, Sierra. I'm sorry.
It has a minimum or a maximum.
Yes. Very good.
Critical numbers.
Yes, I can add that, because if there is no critical number, there is no maximum. Perfect. Critical numbers. Good.
Increasing or decreasing?
Yes, increasing interval and decreasing interval. Awesome. So increasing, decreasing, min, max, of course, if there is a critical number. And we have to analyze it. Okay. Awesome. Excellent. Only if f of x has it
Critical numbers, and it may have max or min.
keyword. Awesome. Brilliant. Thank you so much. Remember we said if there is a critical number, there is no guarantee there is a min or a max. We have to study the sign of the derivative. So critical numbers, after we determine them, we have to study the sign of f prime. If the sign of f prime, I shouldn't write it twice, but you know what I mean. It must change sign. Otherwise, there is no max min. Okay. Now, the second derivative of f of x gives.
Concavity.
Yes. Either holding water or not.
Inflection point.
Very good. Awesome. Function f of x has inflection points if
Zero undefined.
excellent. And f second derivative, the second derivative of f
Changes.
yes. If it changes sign at that point, oh, I should have continued, then, oh, I probably had got a phone call or something, I didn't finish. Then it has a or more
Inflection.
yes. Awesome. So this is basically everything in chapter 3, to be honest. From this moment on, we only continue with applications. But this is it. If you understand these concepts, you have no difficulties moving on. Okay, so I think we should go to 42. And I believe you did not have any difficulties differentiating, that you probably had difficulties with the algebra part. So we are asked in 42 on page 291. It says we're given the value of two properties, t years, so t is in years, and this is in dollars. Okay, how many years after will be the combined value of the two properties be a minimum? Good. So what do we have to do in order to find a minimum? Find minimum.
We have to find a prime of t.
A prime of t. What will be the second step after we find a prime of t?
set a prime of t equal to 0 and undefined.
Exactly, brilliant. And then, assuming we get critical numbers, what do we do with them? We always did that in a table. What do we have to do?
Find the sign.
That's it. We have to study the sign of A prime. If it does not change sign at these points that we find, then there is no max min. Awesome. Good. So, when we differentiate this piece, we have to differentiate e to a function. E to a function prime is e to that function times the function prime. So I have to multiply this number by 10,000. 10,000 has 4 zeros. So I have to move the decimal point 4 spots to the right. So then I get 250. E to 0.025t. Here, this is a negative number, so when I differentiate, it will be negative 0.04, right? Times e to negative 0.04, and times this. So you got that.
Is it 600?
So 15,000 multiplied by 0.04. 600. Excellent. Yes. Is that what you said? Sorry. Yeah.
Yeah, I said 600.
Thank you.
I thought it's not 0.4, negative 0.4.
Did I copy the problem incorrectly? I do that a lot. Is that what you're saying?
I might have copied that problem wrong, but let me see.
I
thought it was
I'm
0.04.
I am famous for copying wrongly. So you're saying that it was this number that I copied incorrectly?
I'm checking. Hold on.
No, but is that what you meant? That there is a
Yes. Yes.
I'm looking at the book right now. So it is correct. So here it is. I don't know if you can see. Okay. Good. So now we accomplished number 1. In number 2, this always exists. This always exists. It's an exponential function. So we're not going to have anything from undefined situation. But I have to solve this equation. So I have 250 e to 0.025t minus 600 e to negative 0.04t equals 0. So I'm assuming that that was a difficulty. So let's do this together. So 250 e to 0.025t minus 600 e to negative 0.04t equals 0. So here's what how we proceed here to find this solution for t. So these are not like terms. We cannot combine them. So because as you see, the power is different. We have to divide by one of them because this will never be 0. As you know, remember the graph. This will never be 0. So I can divide by this. So I'm dividing both sides by e to negative 0.04t. It's never 0. It's legitimate to do it. So when I divide here, I have 250 e to 0.025t over e to negative 0.04t minus 600. This over this will be 1 equals this over this will be 0. Now I combine this by copying the base. What do we do with the exponents? Anyone remembers what we do with the exponents when we divide?
We have to from 0.025 and then it's going to be plus 0.
Yes, we subtract them. Yes, yes. So we have 0.025 but plus 0.04. So we have 0.065. So 0.065t with 250 in front, I move 600 to the other side, and of course I'm going to divide by 250 now. So I have e to 0.065t equals 600 over 250, or 60 over 25, and I don't need to do anything else to this number, I mean. I apply natural log to both sides and I get t. So this is how we handle such a situation. So natural log of e to 0.065t equals natural log of all that. I don't care what it is. I'm going to plug it in the calculator. So then I have this in front, natural log e. How much is natural log e?
Is 1.
Very good. So 0.065t equals natural log of 60 over 25. So then t will be this entire number, do not separate anything, over this number. And then I will approximate. So I have the calculator ready. Okay. So we had natural log. What was it? 60 over 25. Do not separate those two numbers. And divide by 0.065, and I get approximately, and that was in years, 13.5, approximately 13.5 years. Oh, I have a chat. Is it for me? I see. Good. Okay. Is this clear now?
Yeah.
All steps. So we determined the critical number. We found this critical number. Now it's asking us to find, it says find the minimum. I don't trust this. I don't know if this gives a minimum. I have to show that it gives a minimum. So in my step 3, I will just do this. A prime of t from 0, because it cannot be a negative number. 13.5, 0 here, whatever, I don't know. And I will study the sign. I have to convince myself that this gives a minimum. I don't know. So what I'm going to do, because this is not a simple polynomial function, I'm going to plug this in, the derivative. I'm going to plug this in the calculator. Then I'm going to plug in a number between 0 and 13.5, and I'm going to plug in any number you pick. Doesn't matter. You can tell me which number you want to pick between this and this and between this and this. If the sign is not negative here and positive here, then I'll say, oops, this is wrong. Who knows what I did? But I have to check. So I will put the derivative in the calculator. So here it is. In y equals, clear whatever you have, and I have 250, and I have e to power 0.025 t, close the parenthesis, minus 600, because remember we studied the concepts. That's the most important thing. I don't trust anything before I check. It says find a minimum. I don't know if that's 13 point something something 0.5 is a minimum or not. Then I go to the table, and please give me a number between 0 and
13.
which one?
13.
Okay, it's quite close, but that's fine. And if the answer is not going to be a negative number, then I'm in trouble. It is a negative number. Now please give me a number from 13.5 to whatever.
20.
Okay, 20 it is. If the answer is not positive, then I'm in trouble. But I checked. So now this is guaranteed. It's negative here, and it's positive here. So then they're asking us to find the minimum. I have to plug this number in the function. This number is guaranteed to be the relative minimum. Well, in this case, it's also an absolute, because it's it's coming this way. So it's also absolute. But I have to plug it in the function because they're asking me to find the point. The point is not this. The point is x comma y, or t comma f of t. So now I go back to the calculator. I plug in, I don't need this, I plug in the original function, which is 10,000, and e to 0.025t, close, and then plus 15,000 e and parentheses negative 0.04t, and close. And now here is when I plug in that 13.5 approximately. I truncated the number, is not exact. If I want to be super exact, here's what I would do. I would put in so that the calculator calculates this by itself. Again, 60 divided by 25. 25, close, and divide by 0.065. And now I will be as close as possible to the actual minimum. And I want to see it. And the minimum is 22,755.61. 22,755.61. This is the minimum. What is the point again? 13.5, x, or t if you want, comma, 22,755.61. Good. It was a very good problem. Anything else you have for me? Other questions from my lab math or from anywhere else? Anything else you would like to work on? Or can we continue?